So looking at exponential growth and decay. So there's regular exponential growth and decay, and then there's continuous exponential growth and decay. We'll look at both of them separately. So let's just start with regular exponential growth and decay. So there is a formula. We have A equals P times 1 plus or minus R to the power of T. A is the value that you end up with, P is the value that you start with, R is your rate as a decimal, not a percent, a decimal or a fraction, not a percent, and T is the length of time in terms of the time relevant to your problem. So let's say that I have some population, we'll keep the numbers small, some population, I don't know, let's say it's 375 bunny rabbits, and they multiply at a rate of 6.75% per day. And I want to know how many rabbits will I end up with after 6 days. So I have my starting population, this is my P, my 375. I have my rate. It's written as a percent. I'm going to need it as a decimal or a fraction for my problem, so let me go ahead and convert that real quick. So I'm dividing by 100, so 0.0675. And I have my time, 6 days. So to find the number of rabbits that I'll have at the end of it, I just plug in the values that I know. Now, they increase by 6.75% per day. Since this is an increase, notice in the formula I have plus or minus. The plus is for growth, if my population or whatever I'm talking about is getting bigger, and the minus is for decay, if it's getting smaller. My bunny rabbits are multiplying, so this is growth, so I will use the plus sign. So A representing how many bunnies I have at the end of 6 days. My initial population is 375. I'll have 1 plus, so 1 is representing your initial value, so 100%, plus the increase, so 0.0675, and T is my time relevant to the problem. It was in days, and I want 6 days. Definitely I'm going to use a calculator to plug these values in. So I have 375 times 1 plus 0.0675, all raised to the 6th power. And I get A is equal to 554.930467 something. Be mindful of what the problem is asking you for. This is talking about bunny rabbits, so most likely the problem is going to say rounded to the nearest bunny rabbit. So this would be approximately 555 rabbits. And of course, if this population was dying off and it was decreasing at a rate of 6.75%, then we would have done 1 minus 0.0675. So just be mindful of that. Another application of exponential growth or decay is half-life. Certainly in high school, you took chemistry and talked about half-life. The half-life of a substance is the length of time required for half of that substance to decay. So let's say that we have an isotope that's 155 grams, and I want to know how much would be left after 3 half-lives. So notice this problem doesn't tell me how long the half-life is. It really is irrelevant. I just know I'm talking about 3 of them. So my length of time is a half-life, whereas in this one, the length of time was days. So the time will always just be relevant to your problem. This time is a half-life, so 3 of them are going to occur. What is left out of here is the percent that it's decreasing by. Well, the half-life tells us. Again, by definition, a half-life is the length of time required for half of the substance to decay. So our percent, or our rate, is 50%. It's going away by half, which is 0.5 or 1/2, right? However you want to write it. So there is our R. So if I want to know how much of this isotope is left after 3 half-lives, I have A is equal to my initial mass, which is 155, times, now this is decay, right? Half-life is, again, how long it takes for half of the substance to decay. Since it's decaying or decreasing, I will subtract. So it's 1 minus 0.5. And this is 3 half-life, so my time is 3. So I get 155 times, I'm going to write it probably how you saw it in high school, 1 minus 0.5, which is 1/2 to the third power. That might ring some bells. If not, that's totally fine. We're just going to put it in our calculator. So 155 times half raised to the third power, and I get approximately, it's 19.375. I'm going to round it to the nearest tenth, 19.4 grams. Again, be mindful of what the problem asks you for. If it rounded to the nearest gram, this would be 19. I rounded to the nearest tenth, so just make sure that you read that in your problem. So this is regular exponential growth and decay. I didn't write out all the problems, but let's take a look real quick at exponential. Continuous exponential growth or decay. So the way you'll know if it's continuous or not is it will explicitly tell you in the problem that the population or whatever it is follows a continuous exponential growth model or continuous exponential decay model. It will explicitly state in the problem that it is continuous. It's usually going to be in italics, you know, little slanty words, so you can't miss it. So be looking for that. If you see continuous exponential growth or decay, then we are using this. The formula for continuous is PERT. So A, again, represents the value we have at the end of the growth or the decay. P represents the initial population or mass of the object. E is that natural exponential. R is your rate, and T is your time relevant to the problem. So let's say that I have some population of 1,000, I don't know, monkeys. And due to deforestation, this population is decreasing following a continuous exponential model at a rate of 3.75% per year. And I want to know how many will be left at the end of 7 years. So let me come back up here real quick, the plus or minus. So positive again is for growth, the minus is for decay. So this population is following a continuous exponential decay model. So they're decaying at a rate of negative 3.75% because it's decaying. So let's plug in. Again, I'm just following the formula. And I want to know how many monkeys will be left. So I have A equals my initial population, 1,000. E, again, is just that exponential, the natural exponential. Since I'm decaying, I didn't say that, but they are decreasing at a rate of 3.75%. It's negative, and just like with the regular exponential growth and decay, I don't want to use the percent. Either you want to use a decimal or a fraction. So I have negative 0.0375, and then times my time, so times 7. I am obviously going to use a calculator to calculate that. Be very careful, depending on the calculator that you use, that all of this is inside your exponent. Right? Alright, so I have 1,000 times e to the negative 0.0375 times 7. So after 7 years, we'll have approximately 769 monkeys. Again, I just rounded this to the nearest monkey, but be mindful of what the problem asks you for.